Dear students, let us to continue the remaining questions on electric current. So the question is, write the relation between the resistance and resistivity. See, we can write resistance equal to resistivity into length divided by area, that is R equal to rho L upon A. Clear? Okay. So the next question is, how does the resistivity of a conductor vary with the temperature? So directly proportional. How does the resistivity of a conductor vary with the temperature? So that is directly. So it means as the temperature increases, resistivity also increases. The next question is, how does the resistivity of a semiconductor vary with temperature? This one is the semiconductor, so previous one is the conductor. So decreases exponentially, means rapidly decreases. Okay, and if you plot the graph of resistance or resistivity versus temperature, for a conductor we are getting it is a straight line, and if you plotted the graph of temperature versus resistivity, so it is exponentially decreases. So means we are getting a curve here. Okay, so now what is the cause for electric resistance? Collision of free electrons with ions. The next question is, what is meant by electric conductivity? The reciprocal of electric resistivity is called electric conductivity or simply conductivity. Okay. Next question. Write the SI unit of electric conductivity. The SI unit of electric conductivity is Simon per meter. So that we can write S bar M or S M raised to minus 1. Next question is, what is drift phenomenon of electrons in a conductor? It is the phenomenon in which the free electrons experience a force opposite to the direction of external electric field. The next question is, define drift velocity of electrons. Define drift velocity of electrons. This question may asked in 2014 March and 2018 March. So the drift velocity of electron is defined as the average velocity with which free electrons of a conductor move in a direction opposite to the applied electric field, and that average velocity of the electron itself is the drift velocity. Define relaxation time or mean free time. So it is defined as the average time interval between successive collision of electron. Next question, define mobility. See, this question is also repeated 3 times. March 2014, July 2017, and also March 2017. So mobility is defined as the magnitude of drift velocity per unit electric field. If the applied field is 1, then the magnitude of the drift velocity itself is the mobility. The SI unit of mobility, that is drift velocity itself is the velocity, that is meter per second, and this one is the volt per meter, so we'll get meter square volt second, okay, or meter square per volt per second. Clear? Okay. Write the factors on which the mobility of a charge carries or charge carrier depends. The temperature is the answer. Write the factor on which mobility of a charge carrier depends. It depends on its temperature. Next question is define temperature coefficient of resistivity. Temperature coefficient of resistivity. Fractional change in resistivity per unit rise in temperature. Fractional change in resistivity per unit rise in temperature. So the SI unit, write the SI unit of temperature coefficient of resistivity. See, the temperature coefficient of resistivity is fractional change in resistivity. It is unitless because change in resistivity by original resistivity. Per unit rise in temperature means the unit of SI unit of temperature coefficient is the per unit of temperature. If we measure the temperature in terms of degree centigrade, then the unit is per degree centigrade, or the SI unit of temperature is Kelvin, so we can write per Kelvin. Okay, so as per the question, the answer is per Kelvin because the question is write the SI unit of temperature coefficient of resistivity. Okay, so the next question is write the expression for ohmic loss in a conductor carrying current and having resistance. So the ohmic loss is I square into R, that is power. Then the question is, what is EMF of a cell? the potential difference between the terminals of a cell when the cell is in open circuit. If the cell is not in use, then the potential difference between positive terminal and negative terminal of the cell itself is the EMF of the cell. The next question is, write the SI unit of EMF of a cell. So EMF of a cell is measured in terms of volt. The next question is, define internal resistance of a cell. Define internal resistance of a cell. The resistance offered by the cell to the current through it. Okay, the resistance offered by the cell to the flow of current, okay, or current through it is internal resistance. Then the question is, define terminal potential difference. So terminal potential difference is the potential difference across the cell when the cell is in use. So the potential difference between the terminals of a cell when the cell is in closed circuit. So it means if you are applying the load, okay, to the cell, then the potential difference gives the terminal potential. When the cell is not in use, and if you measure the potential difference between the terminals of the cell, that one is EMF of a cell. Clear? And both are measured in terms of volts. Remember, the unit of terminal potential is also volt, and the unit of EMF is also volt. That is electromotive force. EMF means electromotive force. Okay. So these are the some important questions. Write down all these questions in your book. Okay. So thank you once again. And some questions are remaining, so that we can discuss in the next class. Okay, thank you.